All right, I think we're ready to get started here today. Um, so couple announcements. We've got the STEM Fest job fair Thursday during class time and afterwards at UMD, run some 10 until 2, and there'll be transportation. I assume leaving from the Mitchell parking lot is where they usually leave. So if you want to sign up for that, you can. And then next week, I haven't posted yet, will be the business job fair over there. And most people just go to one or the other, but as computer students, there's a fair number of computer jobs listed in this, even though it's kind of an engineering fair. But again, there's a fair amount of computer jobs there. And same with business, even though it's a business, there'll be a fair amount of computer jobs there. So you'll get a chance. So here's some of the jobs that are listed here that'll be hiring here. I don't think CIS will be there, but CIS has just released all their summer 2025 internships, although some of them are co-op, so can start in January part-time or something like that here. Those are good ones to apply. We've had students really enjoy the CIS internships. CIS is a cool aircraft manufacturer, one of the cooler employers, I think, in Duluth here. So start looking at that. The other thing is that DigiKey is here today. So after class, some of us will walk down to the writing center and go to the classroom in the writing center. And I believe we're having pizza there, and DigiKey will be there. You can also sign up for interviews. They have interview times tomorrow available. So they have slots from 1 until 3. If you 1 to 4, basically. If you can't find those slots, just put your name down as someone who's interested in there, and we can see if a recruiter can at least reach out and talk to you. They'll also be they'll have a booth at the STEM fair on Thursday also. So, okay, so those are the main announcements. Okay, second announcement. So we'll have our first guest speaker today, tied in with DigiKey. So Steve Mueggenberg will be here. He's 2019 grad and has been working at DigiKey and is coming here and will be here in person because he's part of the recruiting team here. So he'll be here. And so I'll talk to about 11, and about 11 till 11:30, 11:40, we'll have Steve and talk stuff. So that'll be part of today's schedule. We're actually going to start kind of coding today and going over Unit 2 and start looking at C# and comparing Java to C# in a number of different ways. One problem we're having is Microsoft stopped supporting Visual Studio with Visual Studio 2019, and we had actually been using Visual Studio 2019 the last time we taught the class, even though it was a little bit old. But now we switched to Visual Studio 2022, and that's not available on the Mac. And so what there is another product from Microsoft called VS Code or Microsoft Code, which is actually quite a popular product out there. And so we're going to kind of transition to that, at least for the Mac users. I'm setting it. I've got VS Code running on my PC. I'm trying to get a good Mac and run on Mac and record some videos. So today, the basic stuff that we'll be doing this week shouldn't be the problem. What I'm trying to run into is a couple of the more advanced labs later on in the class. A lot of them use GitHub and Git, and I'm going to record a video probably on how to do that on a Mac and what we have to do there. It's a little slightly different, of course. And then also we do a couple of the of our projects involve websites and setting up websites and that stuff. And I haven't tested those out in VS Code on the Mac yet. So I'm still going through some of those since I didn't realize that VS Code wasn't, Visual Studio wasn't supported on the Mac anymore. Like how Microsoft just decides, oh, we're no longer going to support that.
Happened 10 days ago.
Right. So that's where we're at. So yeah, so if you have a Mac, you can just download VS Code. I updated the link here if you just need the link to it. But I don't know what of the plugins and stuff you're going to need. Basically, we just needed to do C# today for that. And we don't need any of the, eventually we're going to need the .NET like 8 framework and that sort of stuff installed there. But again, I'm still, before I post that in detail, we don't need it yet, we'll tell you. So, all right, so let's look at some Java versus some C# stuff here. So I'm going down to Unit 2, and I'm just going to go into this. Some samples of Java and C# and look at some of these samples here. Now I'm just gonna bring up and look at samples and kind of do a side-by-side comparison of these and kind of look at them. So on the left-hand side, we'll have a Java sample. On the right-hand side, we'll have a C# example. And we'll just bring these up in GitHub here. I'm actually going to then move these into their respective compilers because I like the highlighting and the editing and stuff like that a little bit. So I'm actually going to run NetBeans as our Java compiler, because that's probably the last thing you did in 2087 here. So you don't have to run NetBeans, you don't have to compile the Java stuff. But again, I'm just going to show you this stuff. And this is just going to be a simple console kind of app here. So I'm going to open up NetBeans on the left side here. I'm going to do a new project. We're going to leave like we did in is an Ant project. And this is going to be just going to make this a generic CIS 3285 sample project, because I'll swap code in and out of here today. It's going to clean this up a little bit with this stuff we don't need, the comments here. Okay. So then I'm going to take our Java program here and just paste it in there. The package is going to change, so I'm just going to not worry about the package and the class here. So I'm going to take grab the main stuff and copy that in. So I'm just going to copy this main stuff in here, top of that brace, and paste it in for this main. Now the scanner, I didn't grab the import, so I'm going to make sure I'm going to have it just do that import of scanner that util here. So again, this is just I can run this code. And reduce the font a little bit in that window. Okay, enter the filing status: 1 for single, 2 for married, filing jointly, and stuff like that. So I'm going to say I am married and filing jointly. taxable income. So I'm going to say I make $57,000 and there's my tax with that. That's all it does here. So again, remember back to Java, we have our package, we have our import, we have a public class and a public static void main. This is our main method. We declare variables like a double tax and we initialize it. We declare a scanner to get our input. We do system.out.println to print something out. And we have our input here, whatever that was called, whatever our scanner was called, and we use that to say next int to read in the next int. And then we have these if-then statements here. So I'm going to do the same thing in C#. Now, I could just take this version in C# and paste over there, but I'm not. I'm going to actually take the Java version and paste it over there. So let's just see, just to see how much changes we have to make here. So I'm going to create a new project, and we're going to create a console project. And we'll just go into a interest. Oh no, this is our income tax. So again, one thing I want to know is I do a console write line. This is my hello world. I can run this. Now I'm just going to take all the Java code here. Oops, it's running hello world. Look, hello world. There we go. I'm going to take this whole Java code and paste it over here into my C#. And start looking at where I might have problems, where things are different, and talk about those. So the first thing is the name, what we would call a package in Java, we call a namespace here. So in Java, we have these packages and they generally denote folders in our project area. So when we have a package, it means we're working inside a folder and then we have things in there for that. And there's just a way of organizing your code more. In C#, this is, we don't have a package, we have a namespace for this. So we say namespace for this. And again, one of the ideas of this is that if you declare like a global variable, a class name or whatever, it's in that namespace. And you say, well, how likely is it that you'll be using the same class name as another, two places in your project? Well, in big projects, that gets actually pretty common because you often have these generic spaces for like a date or maybe the inventory or item or something like that. And you might be creating one and in the sales part, and the inventory people might be, or the database people might be creating something similar in their area. And they're not actually the same, but you might call them the same thing. Like, if you all work at, maybe a time, purchase time or something, something that's particular to your area there. So the name, we do namespace here. Now, the other thing is that we don't have to do these imports here for this because scanner is not imported. We'll see how we do that in a little bit, but we don't have to do an import for the scanner class. If I can make this a little bigger here, there. The comments work the same way here. Public static void main is the same. That's all the same. The way I declare a variable, double tax equals 1.0, that's the same here. The input, again, I don't need a scanner here, so I'm going to get rid of that. So basically, one thing we'll largely see is a lot of the input and output will change here. So the way I don't need a scanner. And also system.out.println is just a write line. Yeah, is a console write line. So rather than the system.out.println, it's console.writeLine here for that. But the way it's formatted and stuff is just that, you know, I can just have quotes and have that there. So that's going to be the same for this. So as far as reading in, so I'm going to read in an integer here. I no longer do this input for this. So I will do a console.read here. So I might do a read instead of, so again, what I had before on the other side was I had a input, you know, I declared my scanner input next line. So I just do console.read. One thing you will notice is that a lot of languages have really weird console input and output stuff. And it's just a lot of beginning students go, why aren't there better systems for doing that? And to tell you the truth, the reason is that no one other than students do console input and output generally. You use it in Java 1 and Java 2, but once you get out, you know, any real program is going to have like a GUI interface or some other interface. You're not going to do console input and output generally in your programs, or very rarely here. If you do, it's just writing to a log file or something like that. So that's why a lot of the, like Microsoft, you know, has it, why it's different and why it's so kind of strange in there. So again, I can read my status do console read. We'll come back to that in a little bit because that might not work the way it is, but I'll leave it there for now. Again, similar here. I just have to watch any of my print lines and change them. I'm just going to grab this console write line and paste. Here's another system.out print line. Here's another system.out.print line here. And again, for my double here, I'm going to change that to a console.read line. So it's a lot of it is just this input and output stuff, because again, that is somewhat unique to these console inputs. Now I have this big if statement here with an else. I have a switch statement on the status. I have all these cases, all these comparisons, all these assignments, all this math. None of that has to change. All of that stuff, if statements, case statements, loops, all that is the same between Java and C# here. So all this code, all this stuff is exactly the same here. But again, the one thing that's different is this output. There's console.write line. So, oops, I ended up with some extra here for that. So again, of all of this, I changed the package to a namespace. I changed the input and the output. And it looks like it's going to run just fine here. So let's try. So we ran it before here. I said I'm single and an income of 57,000, and it told me my tax 6,400 something. So here I can run the same thing. There are build errors. So let's go look at where are my build errors in here. Oh, does that contain a static main? I thought I had that. Right. So the other thing is that the way to declare the main, it has to be a capital M. So static void main, static void capital M main here. Now let's see if that'll be happy. And that's one thing you will see with C# is there are a number of little places where one of them will capitalize it and one of them won't. Like a lot of the math libraries, like if you want to do a square root or you want to raise something to a power, in one language it'll be a lowercase square root, in another one it'll be an uppercase S on square root and stuff like that. Same here with main. So you see some of that stuff. So. Okay, I'm going to be married again. And here's where I got into problems here. I put in a 2 and got an invalid input here. And I got an error with my input. So how I'm doing input is not quite right. So I'm just reading something and saving it as an int. And I have to do a conversion to do that. So the best way to do that is basically I'm reading in a string and I need to convert that to an int. So here I want to do it this way instead. I just don't want to say int. So like in Java, you can say next int here. Here we just do a read or a read line. So I'm going to do a read line, but that's going to give me a string, and I'm going to convert that to an int. So I'm going to use convert to int here and get that set up. And the same thing down here where I read in my double, my income for that. I'm going to convert that to a double. So I'm going to, rather than saying console.read, I'm going to surround that with a convert to double. And then put the read inside a convert to double. I could read into a string and then change that string into a double, but kind of match our code, I'm just going to do it on one line here. So I'm going to do a read. I'm actually going to do a read line here and convert that to a double. So those two change here. So again, now hopefully this will work. Income. And it calculates my tax there. And that's the same value that this Java program was calculating. So again, not that much different between, and that's again what we're kind of looking at is where do we see differences? Now this one didn't have that much. We didn't have like multiple classes inheritances. We didn't have arrays or stuff like that. So let's look at a little more complicated one. Any questions on this one? So that was this interest calculator here. Let's try to do some classes and set up a this bank account. And again, I'm gonna bring this over to NetBeans here. So I'm gonna take my main and copy it over here. The NetBeans. I'm gonna get rid of this whole main here. Put in my new main. But now I have a class count class, and I've got that in the same file as this other one. So I'm going to do the same thing there. Now, often we put classes in a separate file, but here, just to keep it simple, I have a class in the same file. So I'm going to, after my first class here, I'm going to go outside that class and paste in my account class here. So now I have my account class here for this. I have an error here where this balance is wrong. I misspelled it, so I'm going to correct that. This should actually be balance, and then I'll be happy. Okay, any other errors here in the? And here I don't actually have any input, so I don't actually need my scanner to run this. So this is just a simple bank kind of account. I start with a balance and interest. It calculates interest that is on that balance for this stuff. So again, let's take that same thing and move it over to C#. So this is in Java. Let's do the same thing in C# here. So again, I'm going to actually just take this code from NetBeans. I'm just going to copy it all and paste it all into here. And again, packages have to be changed to namespace. And system.out.println has to be changed to my console.writeLine. But how I declare a class, this class account here, and how I declare methods in there, pretty similar. The way I create an object of type accounts, I need an account object, so I say account, and I'm going to call it my account, and I say new account, and I call the constructor with some initial values here. So that all works out pretty well the same way here. So now, one thing we're going to run into is, and let me switch so I can seem intelligent if I can see what's the answers are here. So, so the date and time sort of stuff here. So I want to grab the date and time. And again, in almost every language you switch to, you often see the date time sort of stuff different. And also, like, you see the same thing in different versions, like of SQL, right? If you're using one SQL versus another SQL, sometimes the date time, that there's not as standardized things for date times as there are for, you know, like int and double out there usually. So you often have to watch date time stuff. So again, we declare a variable here, the date the account was created here, and we're getting the current date here. So this is how we did it. One way of doing it in Java here. But we're going to do it differently here. We're going to do it as a date time field here. So again, we can just say, let's see, yeah, it's date time system, date time. So system.datetime instead of Java util date here is the date created. And again, a lot of times when we say date, we mean date time. We need a specific, so it's not, it's certainly the day, month, year of it, but also it can include the time of the hour, the day within there. So almost every time when we say date, or we mean date time, and sometimes you'll see it as date time here. So that's here. Now, how do we get today's date here? So we don't do the date. We should, I think it's a now. Let's see, what is it over here? Oh no, we just create a new date time. So again, similar, we just do a new system dot date time for that. Um, Another thing we have to watch. So let's go back to this Java one and see something here. So let's talk about constructors here. So we have an account class here. And then we have two constructors, one without any parameters and one with some initial parameters. So these are both for creating a new account here for this. But one of them is doesn't have it, is kind of the default parameterless constructor. And this one we specify ID and balance. And if we specify ID and balance, we save those. But with a generic account, we just set the date created. But this is it. What does this code do here? So this will call the default constructor. So this parentheses calls this default constructor up here and sets the date time stuff. So we have this constructor with parameters calling the, and then again, sometimes we'll call a parent constructor inside a child constructor also with something like this. But here we can't do that for this. So we can't do this. We can't say this. So we can't call that constructor like that. So we just have to take this code that was in that default constructor and move it down here. So then we kind of have duplicate construct, code there, but I mean, we could pull that out its own other method. But again, one constructor cannot call another constructor in C#. Let's see, anything else? So we have this get, balance, getters, and setters here. We have those available here. And let's talk a little bit about that. So very similar here. We can get ID. Now we'll look at some ways of changing these, but the default, the old familiar way of declaring local variables, here, an ID, a balance stuff, and declaring getters and setters works fine in C# for this. ToString is capital T and 2. So again, just a small change in capitalization. So rather than saying ToString with a lowercase t, it's ToString with an uppercase T for that. But again, you can declare. We will, like I say, look at a different way of doing these local variables and these getters and setters called attributes. But you can do it the old way, and you still see a lot of people doing the old way here. We get an error here, and we actually had that same error over here. We just never used it. I'm trying to remember. So this error is here too, where this is annual interest. Is a static variable. So where is that at? So that is declared as a static variable up here, meaning for this. We can't access that. Let's see if this will still run. Yeah, it'll still run, I think, because we never, no, there, we won't. Okay. See, in Java, it lets us run that. Here, it won't actually let us, doesn't?
It says private double annual interest rate.
On the bank account, private.
Oh, I didn't grab the one from Java.
Yeah, the Java one has a static in there, and so we have to get rid of that part. There's some where again it was a warning in Java. Here it is, and so we're trying to access this static variable, and we have to get rid of it, just make it a normal variable here. So then, oh, and the other one is the main. We forgot to change. So the main method has to be a capital M. So again, toString is uppercase, main is uppercase for this to work. And then I'll do our calculations. Fine. So again, most of the ways you build a class, declare a class, use objects are the same between Java and C# here. Okay, let's do some that maybe we won't walk through these quite so much. Let's look at some of these other ones then now. So here's an author class. Let's see. So again, here we're just declaring a class in its same author in a file. So we have public class author here, and we're declaring some private data members, private string, name, email, gender, and we have a constructor, and then we have two constructors for that class here. So similar over here, we do have our namespace set up here. Also, we didn't mention this, but in C# now, if we start using things like arrays, we'll be doing using instead of, what do you have to, you do include? Import. Instead of doing import, we say using and then the different things for this. So there's a couple using statements here. But other than that, here we have our class author. We have our private data variables here, our constructor, two constructors here for this. We have our string variables with a capital S, char, bool. Now here's one thing you'll notice is that Boolean in Java is bool in C# here. And then we have so we had our getters and some setters here, and then we're declaring those getters and setters down here for this stuff. And again, this stuff is very much the same for this our two string methods here. Now here we're declaring our own toString method, so we can declare that as lowercase, although it is much more consistent in C# to make that with an uppercase here for this. So again, the way this is set up is very similar here. Let's look at a this book author test, and let's bring this other one. So again, this is a main where we're testing this out here, and again, just main with a capital M, console.write line instead of print system.printouts. We're creating new books and new authors here. Those are all exactly the same for this. The way we're calling methods in our classes are the same. It's only the outputs that are different in this sort of stuff. So yeah, not a whole lot of differences between these two. Let's do arrays and array lists here. I thought I had this in GitHub, but I still have it as a zip file. So I'm gonna have to download this. I'll download it and we'll put it up here. I'll change the link so it's GitHub here. So okay, here's the code in C# for this. So again, to declare an array of like strings, we just say, you know, whatever private or public, and then string, and then square brackets, and the name of the arrays. If we have an array of some object, we'll say, you know, like private, and then that object, and then the square brackets and that. So that's the same as in Java. And then to access those, we would just say, like, here's our array called days. We can say days sub 1 in brackets equals days sub 2 here. We have to initialize this with the new array. So days equals new array of strings 7 here. Same with this for creating a bunch of points and setting those points up on the constructor for points. So that is basically the same in Java or C# here. Passing an array to a function, like we're saying, I want to print out this. So again, I have a public void function called print array. I'm passing it a string array called A. I'm looping through that length of that array. And I'm writing that out here. Now, I think that's the same. I thought I had this code in C# here, but I'm not seeing it. So, but again, I think all of this is basically the same. I don't remember how in Java, how do you get the length of the array? It's the array name dot length. Is it with a capital L?
Lowercase L.
It is lowercase, yes. That's right. So here it's a capital L for the length of the array is different. But again, most of this, the way we print out all the elements in the array, very similar for that stuff. So now array lists are a little bit different. So let's look at those. So to do an array list, you'd say private array list, and then the name of the array list, and you'd to instantiate or initialize it, you'd say new array list with parentheses here. And there's also a list here, so you can say private list of points and that stuff here. So and then you can do a list of these objects here also. So you can do an array list or a list here. So if I remember correctly in C#, array lists are not typed here. You don't have to say what type they are when you create them, but lists are typed. So when you create a list, you put in the template here what type of object that is. So we're going to create a list of like my points here. Similarly with array lists in Javas, we don't access them with square brackets. We say the name of the array, and then like if we want to add it, we say dot add. But again, I think this is a capital, and I think in Java it's lowercase. You'd say dot add lowercase here. The access a point here. Let's see if we're here we're accessing this, and we can if we have it a list, we can access it with our square brackets like we do with an array, which is a little different here. So you can access that. You don't have to say get. What is the Java array list? What dot get, and then the index point. You can just use your square brackets here with a list for this. Tell you the truth, a lot of times we're not necessarily doing that. So like here we are doing for each loops. So we say for each string s in a. So a's are array list. For each string in that array list, we're just printing that out. So a lot of times with array lists and stuff like that, you shouldn't. Again, we always teach you in Java 1 to do the for I equals 1 to the length and print out each other. In reality, you should probably rarely be doing that. You should be using for each loops almost all the time, unless there's some reason you want to be counting at the same time. For each loops are generally much more efficient for that. So you should be using for each loops. And again, you should be doing that in Java also, but again, we don't teach that quite enough in Java 1 and Java 2. So if you're not used to for each loops, we'll be using those a lot in here. So you might want to brush up on them, and we'll talk a little bit about it. But again, it's just a shortcut. So like here, rather than saying for int I equals 0, I less than points I count plus I, and then referencing, points sub I bracket I, we just say for each point, my point P in points, and then we can just print off P. So P is assigned each element in the array one by one. Here we did one this way because we had to do some calculations with this perimeter with some information here. So we have to sometimes you do have to do that. So we're referencing not only I but the previous polygon here, something like that. So. Let's talk about getters and attributes. This is one of the main differences here. Let's see. So far, like with Java, you've been taught how to do encapsulation with a class. So you declare a class, you declare a private variable, and you declare a getter or a setter to set and get that. And the getter and setters are public, but the variable is private. So you can change this underlying structure and keep the public getters and setters the same there. So you've been taught how to do that, which is good there. But you can do that exact same thing in C#, but there's also properties here, and properties are kind of strange when you first see them here. So here's our person class here, and then we're saying string name. This is like here, private string name, like we did here, private string name. But here for the getters and setters, we do this, we create a property with the same identifier as this one, but in this case, it's capitalized, which is common structure thing. And then we have these simple getters or setters defined in here in kind of a shorthand notation. And we can actually make it shorter than even this here. So what this is doing is creating a private thing called name and a public access called capital N name here. And this is our getters and setters here. Because again, how many times have you done getters and setters? They almost always do the same thing. They just return that value, or sometimes they might do a little check in there, check if it's legal, or if it's negative, set it to equal to 0 or something like that. But a lot of times it's just set it here. And so if it's just a getter, we're just going to return the name field. And if it's set, we're going to set the value we're given to the name field. And so this value isn't even defined anywhere, but that's the, kind of assumed value like here for this when we work on. And then you can do things like if you want to set the name of something, you can say like my object dot name equals here, where in Java you'd always have to say my object dot set name. So these properties can then be used just like a variable. You can assign them, you can print them out. You don't have, it's not like a function call or something like that. It will then automatically call the underlying getters or setters. So the getters and setters are kind of hidden from the user in some ways. So when we say my object dot name equals Liam, it's going up here and saying, oh, we're setting name, call the set thing, and whatever values over here, save that to name. And again, you can do some checks or whatever here, but it kind of calls the getter automatically. And same with the setter. Here's calling the setter automatically. And again, if we're printing out this, we don't have to say my object dot get name. We can just say my object dot name, and it will call the getter for you here. Now, there's a short, so I said you can do it this way. If you're just doing this, since this is so common and we're lazy programmers, we've shortcutted that out. So you can declare a name property and you can say getters and setters here. It will automatically create the underlying name for you and declare the getters and the setters, the default ones for you. So sometimes you'll see it declared this way, and often you see it all on one line. These properties for us. And again, it works well. It keeps us from having to write all these getters and setters. It just shortens it up. And then we can access them directly. We don't have to say get name or set name. We can just access this property directly. And again, if you do need to do some boundary checks or something like that, you can then expand this, the getters or setters to do that. So, okay. We'll see these in a number of places, and I'll try to point them out as we see them that, why this is a little different here. But these are called properties in C# for this. Okay, let's start wrapping up here.
Let's wrap it up. Is there anything specific you'd like to discuss before we go?
No, Siri, there is.
No, Siri. I don't even know who's talking to me. It's not. I don't have an iPhone, so it's not Siri.
Sure.
All right. Yeah. So, yeah, interesting. It's on silent mode too. It's still talking. It's not. Maybe it was Alexa. I have the Alexa app. So, okay. I shouldn't say that.
Yeah.
Okay, so here's a summary of our things here. Just watching. He's here. Good. So here's our summary of things. And again, we'll hit on some of this other stuff more on Thursday for this. Yeah, I'm trying to. Think you're tweaking or having an in-class project on Thursday that might be kind of fun, so we'll see if I get there. So. Did you, when you did 2087, did you do his newest class has this. Hug space, these little animals working around a grid. Did you do the little animal in a grid? In 2087, where you could declare an animal or a little blob and have it move around the grid? Java 2?
I don't think we ended up having.
Oh,
It was like the flips. It was like the flip thing.
okay.
Yeah.
Yes, we did do those.
Yeah, so I'm thinking about trying to convert that whole thing into C#. So, okay. Let's bring in our speaker and do that. Okay, I'm going to stop this recording and we're going to start the recording up again.